Hello everyone, this is Teacher Harold, your junior high school math teacher. And in this video, I'll discuss the functions of special angles. After you watch this video, you are expected to define the trigonometric functions of special angles of a right triangle. Then evaluate expressions involving trigonometric functions of special angles. In the previous topic, the lengths of the legs of a right triangle were given, and we were asked to find the values of the 6 trigonometric functions of the angle. Oftentimes, we will, we will want to find the value of trigonometric function when we are given the measure of an angle rather than the measure of the sides of a triangle. For For most angles, advanced mathematical methods are required to evaluate a trigonometric function. For some special angles, however, the value of trigonometric function can be found by geometric methods. These special acute angles are 30 degrees, 45 degrees, and 60 degrees. The value of 6 trigonometric functions of 45 degrees. Suppose we have a right triangle here, which is actually an isosceles right triangle. Meaning, this is a right triangle whose legs are congruent. Okay. The legs are the two perpendicular sides with the same length. Okay. And one of the acute angles is 45 degrees. So in this case, since this is a special right triangle, particularly an isosceles right triangle, meaning that the horizontal and vertical leg are congruent or equal in length, and they are both denoted by small letter A. So if we apply the Pythagorean theorem solving for the longest side which is denoted by small letter R, this is actually equal to square root of 2 times A. Or simply one of the equal legs multiplied by the square root of 2, and that is the length of the hypotenuse. And of course, acute angles A and B are also equal in an isosceles right triangle. The length of the sides opposites of these angles are also equal. Now let the length of each equal sides be denoted by small letter A, as I have just mentioned earlier. Okay, they are both denoted by small letter A. Now using the Pythagorean theorem, we have r squared is equal to a squared plus a squared. Okay, we combine similar terms, so that is 2a squared, and then we get the square root of both sides in order to get the length of r in terms of a. Therefore, your r is square root of 2 times a. Therefore, the values of 6 trigonometric functions of 45 degrees are as follows. For sine 45 degrees, of course, there is a case wherein you obtain a fraction whose denominator has a radical sign. So you must rationalize the denominator. And the value for sine 45 degrees is actually square root of 2 over 2. Now for cosine 45 degrees, basically parang parehas lang ng sine of 45 degrees. So you rationalize the denominator, so that is square root of 2 over 2. Okay. Then for tangent, so that is adjacent leg over, or opposite leg over adjacent leg, which is equal to 1. Then the cotangent of 45 degrees is simply the reciprocal of tangent of 45 degrees, so that is equal to 1. And for cosecant of 45 degrees, you just reciprocate the value of cosine 45 degrees, so that is equal to square root of 2. And for the cosecant of 45 degrees, that is also square root of 2. Which is also which is this time the reciprocal for the value of sine 45 degrees, which is also square root of 2. Next, the values of 6 trigonometric functions of 30 degrees and 60 degrees. Now we have a triangle here, and this is actually an equilateral triangle, and at the same time an equiangular. Okay, so you will notice here that as a perpendicular bisector is drawn, cutting this triangle into two equal parts. A perpendicular bisector is this one that I'm highlighting right now. Okay, it bisects angle A, and at the same time this segment also bisects the opposite side, which is named as segment BC. As a result, because of this perpendicular bisector, this equilateral triangle is divided into two congruent right triangles, wherein each of the two equal parts is a 30 by 60 by 90 triangle. Okay? So if one of the sides of an equilateral triangle is denoted by small letter A, this side happens to be the hypotenuse of this 30 by 60 by 90 right triangle. And of course, segment OB is half of this length, which is A over 2. And the perpendicular bisector, which happens to be the height of this triangle, can be determined by computing for the length of this segment in terms of A. Of course, you apply the Pythagorean theorem. Yun. So again, by Pythagorean theorem, so that would be, so A squared, this is the hypotenuse. The square of the hypotenuse is equal to the sum of the squares of its two perpendicular sides. This one, the horizontal and the vertical sides, happens to be the broken segment, which is, as what I have just mentioned earlier, the perpendicular bisector of this equilateral triangle, denoted by H. So that is H squared. Okay, you simplify this term right here, it's A squared over 4. Then you isolate H squared. So A squared over 4 transposed to the left side, it becomes negative. So A squared minus A squared over 4 equals H squared. Then combine these terms, since they are similar, we have 3A squared over 4, which is equal to H squared. And then you get the square root of both sides, so that we can find for the length of H, for the length of this side denoted by small letter H. So you simplify this side, you have H is equal to square root of 3 over 2 times A. Okay, so this is the length of this height, denoted by H. And with that, we can now declare the values of 6 trigonometric functions for 30-degree acute angle. Right here, this one. Now, applying the SOHCAHTOA code in order to declare the 6 trigonometric functions, starting with the first 3, which is known as the basic trigonometric functions. So, for sine 30 degrees, that is opposite leg over hypotenuse. So, if this is your acute angle, this is the opposite leg over hypotenuse. So, A over 2 divided by A. Simplifying this side right here, you will have 1/2. And for cosine 60 degrees, that is adjacent leg, this one, divided by the hypotenuse A. Square root of 3 over 2 times A all over A. And that will give you square root of 3 over 2. And for tangent 30 degrees, that that is opposite leg over adjacent leg. So that is A over 2 over square root of 3A over 2. And this will give you 1 over square root of 3. So of course, you rationalize the denominator. That will give you square root of 3 over 3. And from this first 3, we can easily declare the remaining 3, because those remaining 3 are simply the reciprocal of this first 3. And these are what? Okay. So for the reciprocal of sine 30 degrees, that is cosecant 30 degrees, of course, 1/2 is the value for sine 30 degrees. And for cosecant 30 degrees, that is 2. You just reciprocate this in order to get the cosecant of 30 degrees. Same thing with cosine 30 degrees. If we reciprocate its value, it will give us the secant of 30 degrees. And that is 2 over square root of 3. You rationalize the denominator. That will give you 2 square root of 3 over 3. And finally, for the reciprocal of tangent 30 degrees, that is cotangent 30 degrees, adjacent leg over the opposite leg. And that is square root of 3. And these are the 6 trigonometric functions of 30-degree acute angle. Okay? At this point, we have just declared the 6 trigonometric functions of special angle 45 degree and special angle 30 degrees. And what remain right now at this point is the 6 trigonometric functions of 60-degree angle. Okay. Now, using the same figure, we can also find the 6 trigonometric functions of 60 degrees. This time, the side opposite the 60 degrees is square root of 3A over 2, and the side adjacent to this angle is A over 2. Thus, the values are as follows. Of course, you simplify. Sine 60 degrees is square root of 3 over 2. Applying the SOHCAHTOA definition or the code for the first 3 basic trigonometric functions. Okay, cosine 60 degrees is actually 1/2. Tangent 60 degrees is square root of 3. Cosecant 60 degrees is the reciprocal of sine 60 degrees, and that is 2 over square root of 3. So you rationalize the denominator. That will give you 2 square root of 3 over 3. And secant 30 degrees is 2. And cotangent 30 degrees is simply 1 over square root of 3. Of course, that is not yet simplified. So you rationalize the denominator, and the value is square root of 3 over 3. Okay? So all in all, we have how many trigonometric functions of special angles? We have 18. Okay? 6 for 45 degrees, another 6 for 30 degrees, and 6 more for 60 degrees. And you must memorize those 18 trigonometric ratios of special angles. And this is the table. Now, the reason is for memorizing those 18 trigonometric functions, you will be needing those values even without using scientific calculators. Okay, so particularly in these particular examples, you will be asked to evaluate expressions involving special angles, like this one. Evaluate cosecant 30 degrees plus secant 60 degrees plus tangent 45 degrees. So for our solution, you must know the values of each of these, since the angular measure involved here are special angles. So cosecant 30 degrees is 2, secant 60 degrees is 2, and tangent 45 degrees is 1. Okay, you replace the value for each term to this expression and then simplify. Yun. So that is 2 plus 2 plus 2 and the answer is 5. Okay. Next, number 2, about this one. Sine squared 45 degrees plus cosine squared 60 degrees. Okay, solution. Note that if we say sine squared of theta, that is the same as sine theta times sine theta, or that is sine theta quantity squared. Theta degrees quantity. So that is sine of the quantity theta degrees squared. Now for cosine squared of theta, that is the same as cosine theta degree times itself, or that is quantity cosine theta degrees squared. Okay? And with that, we can answer number 2. So referring to the same table, substitute the value for sine 45 degrees and cosine 60 degrees. Okay? So that is for sine 45 degrees, that is square root of 2 over 2 quantity squared. Since the first term is being squared, likewise for the second term, it is also being squared. So that is plus quantity cosine 60 degrees is 1/2, so 1/2 squared. Then square each term, you will get 2 over 4 plus 1 over 4. Okay, add two fractions with the same denominator. So we just simply add their numerator. Therefore, your answer is 3/4. Okay. Next, we go to number 3. 4 cosine squared of pi over 3 plus square root of 3 times tangent of pi over 6. Okay, pi over 3 is and pi over 6 are both special angles. So using the trigonometric functions of special angles, so we have cosine pi over 3 is 1/2 and cosine squared of pi over 3 is 1/4. So you just simply square this value. Okay. Next, for tangent pi over 6, that is square root of 3 over 3, you square both sides. You square. No need, no need. Just this one. Okay. So 4 cosine squared of pi over 3 plus square root of 3 tangent of pi over 6. Okay, 4. Then replace cosine of pi over 3 by its value 1/4 or 1/2. Okay. You square 1/2, that is 1/4 plus square root of 3 times square root of 3 over 3. Of course, this one right here becomes 1. And here, 3 square root of 3 times square root of 3 is 3 divided by 3 is 1. So basically, it's 1 plus 1. And we have 2 as the answer for number 3. Okay? Okay, I think this is the last example from this video. And we will see you again next time for the next lesson in trigonometry.